Hey, 10 a.m. Central Time. Good morning, everyone.
Hello, everybody.
Hey, this is Andrew.
Yeah, and this is Alex. It's nice to
That's
meet you
me.
here.
Yeah, 18 time actually with the X technology, and first time with the 2022. And welcome to our new format session. It's called a workshop. Well, its format is called workshop.
Wow, 18
Wow.
time. Man, I cannot imagine that on the beginning of the previous year when everything just started, you know.
Mhm. Yeah, indeed. We should now apply to Google Developer Program. Last time they said, oh yeah, it was not it's not a year, and this is a requirement. So now it's exactly a year. We started last year, 30 January, if I'm not mistaken. So today is gonna be just the two of us, and we try in a new format. We haven't decided yet if this video will stay in our channel history, but maybe it will. So today is a workshop again, and it's gonna be conducted by me and Andrew, indeed. And it's called "How to Convert Cryptocurrencies with gRPC Microservices in Node.js." And yeah, I hope you read this description if you see our stream live, at least. And it's going to be some practice involved in this session as well. So stay tuned. We Are we ready, Andrew?
Yeah, we just can start right now.
All right. So this is the agenda. Let me talk a little bit about it. So our workshop actually is going to be quite big in time, in my opinion. I think it will take at least 2.5 hours today, but maybe even more than 3 hours, depending on how many people will participate in a live practice session. And in general, it consists of three pieces today. So first part is introduction, and in this part we're gonna explain some theory, some must-known theory that is going to be used in a workshop, and it will of course be exploring gRPC protocol buffers, and it will also include some history of these technologies, as well as some more details on how this all works. And in the end of the introduction, I will also show two simple demos just to explore these technologies a little bit more. And this is going to be more like a basic level for more understanding of what is gRPC, what is a protocol buffers data format, a real application. But it's not yet a real application. It's going to be just, let's say the beginning. And then a second part, which is going to be driven by Andrew, it's going to be about a real use case of an application. So Andrew, what was going to be a second part about?
Yeah, so second part is going to be like a microservices structure where we're trying to build in life cryptocurrency converter. But not only cryptocurrencies, but also other currencies as well. So we are trying to combine different providers in our chain, and then in some moment we just start providing a service which called converter, and this converter allows us to convert currencies through the different currency provider. So basically we can ask this provider, okay, I need to see how much 100 Ethereum would be in Canadian dollar, something like that. And it's gonna reply through the old gRPC network, calling the end party providers and returning some data.
Nice. Right. So that's going to be a second part, more demos, more technologies, actually including Lerna and other stuff. I will explain it in a second. And there's going to be a last part. It's called called practice right now. Depends on how many participants and participants who are willing to actually do live exercises. It can last for, I don't know, up to an hour, let's say. And what we plan for this practice session is actually quite interesting, also new format for us. So we prepared a Google Meeting call where we can join and you can ask us any questions about the material or whatsoever. If you would like to also do some exercises, we will be there to help and maybe explain these exercises in more details. If not that much participants will be there, we will do still the live coding in this call. So it's not going to be recorded, but you can watch and yeah, let's see how enjoyable it would be. But yeah, I think at least it would be interesting for us. So yeah, feel free to join, and it would be actually quite cool if you can join it. Yeah, that's pretty much the agenda for today. I just want to say a few more words about the workshop itself, but let's maybe first introduce us, and for that, maybe Andrew, can you say a few words about you?
Sure, why not? Hi, my name is Andrew. I live in the United Kingdom, but originally I'm from Russia. I work as a software engineer, kind of infrastructure engineer, as well as software engineer. So I do a lot of coding. I do a lot of open source contributing, my favorite technologies like Node.js, Typescript, and Go language. And also I'm really in love with all DevOps practices and the ways how we can automate our developer daily basis to improve the quality and speed and just move further and faster.
Mm-hmm.
That's it.
Can I
Alex,
ask,
your turn.
Yeah. Thanks. Yeah, one question, Andrew.
Yeah, sure.
So what's your motivation behind this workshop? Or what's your goal for this workshop?
That's pretty much a good question. I still asking this question for myself, like since last February when everything just started. I mean, I have different ideas in my mind. I'm trying to implement these ideas, and that's just a way to share these ideas with with the rest world and try to gain some feedback and maybe to collaborate all together to in attempt to make something cool in open source. And also, yeah, I want to have some practice speaking. Yeah, that's it.
Nice. Very cool. So yeah, about myself, I'm gonna be talking actually the next 40 minutes or something. So I'm Alex. Hey everyone. I hope if you join our channel, not the first time you saw me. Yeah. So I'm also a software engineer from Moscow, and I currently live in Amsterdam, Netherlands. I'm yeah, almost. Most part of my career was doing JavaScript related things, first in front end, later in DevOps and backend. Last 2 years, I'm working more on, let's say, traditional stack with Java, but also actually experimenting with Go language. So I enjoy trying different technologies, also learning about the theory of those. Last year, we did this technology sessions with how to build your own language, which was called Typescript. So these kind of investigations or deep diving I like a lot, and that's why I was very happy when Andrew invited me to participate in preparing this workshop. Yeah, this is about gRPC. This is a pattern that I haven't tried before we started practicing this workshop material. But again, it's very interesting to me to learn and explore that. So yeah, that's about it. What else? Well, first of all, I will send now a link to the whole workshop description. Maybe if you're bored with what we discussing, you can just go through it yourself. And it has all the links about materials, the code that you can use during the workshop. Some practice exercises also described there. Yeah, it's all here. And yeah, you can also follow us or help us in the other way, whatever you prefer. We are happy in any of these cases. Let's the workshop begin, I would say. And the first part is going to be introduction indeed. So we already started with introducing ourselves. So now, what are we going to do today? And again, this is just a description of workshop itself. So maybe if you haven't read it, maybe it's a good time to check at least the key parts, key ideas of the workshop. By the way, I will hide Andrew for this part. Feel free to contact me. Yeah. All right. Prepare it like that. Yeah. So I send a link to the chat. Hope you can access it and see it. If you have any questions, feel free to, of course, post it to the chat. We will catch them. And otherwise, you can also wait for a live session in the end of workshop. All right. So yeah, I think I already talked about the format itself. So we're gonna do the technology review starting right now, and there's gonna be an example structure explained by Andrew and the practical exercises, 3 parts. Yeah, it's a really middle or advanced level of workshop, we think, and actually it's a first run of this workshop, so it's going to be experimental for us as well. So it's great if you have a JavaScript experience, even better if you have Node.js experience, because some parts will be very, I think, difficult for first-time learners of these technologies. It would be nice if you have already Node.js and NPM installed. If not, please open the website of Node.js and then feel free to install binary from there. And protocol buffers. That's needed, I think, in the last part of today's session. But if you really wanted to try some exercises during the workshop, it would be great to start with installing the protocol buffer compiler. And my examples will be shown with a VS Code IDE, but of course, feel free to use your IDE. And actually, Andrew is using WebStorm, if I'm not mistaken. Yeah, materials, like I said, feel free to reuse them. So yeah, let's go straight to the point. There's gonna be what we're gonna do today. I think we explained which technologies we're gonna use. This is already quite interesting question. This is a list of tags in the end of this page. So first of all, gRPC is mostly used in distributed systems and microservice kind of ecosystems. So it's going to be explaining a little bit of a microservices architecture. Node.js, JavaScript, and Typescript already said. Protobuf, also a technology that is going to be used today. About Lerna, NPM, and Yarn, we not explaining too much of those, but you have some idea of what are these NPM and Yarn, because it's very common to use them in Node.js environment, of course. But about Lerna, we're not going to be touching much of the theory of that, so hopefully you have an idea of that. But if not, Andrew will actually show some introduction example of that. Yeah, so those are the technologies. Now let's begin. What is a gRPC? The first part of the workshop. If we talk about a gRPC, I personally like to start with a definition. So let's spend a couple of seconds just reading the official definition of that. Right. So this is technology or technology pattern that was introduced by company Google. And in this definition, it says many interesting words already. So I highlighted some things that I perceive the key parts of that. So first, it's modern open source remote procedure call framework. and we're gonna talk a little bit about what that means further. And also, it's about client and server client and server communication. Yeah, that's of course it's Google remote procedure calls, like all the Googlers joke all the time, but in fact it doesn't say so. It's just G remote procedure calls. It's a funny story. Yeah, a little bit about history. Yeah, if you Google gRPC versus other protocols used in modern APIs, you will find some alternatives, but it all started in Google ecosystem, like many other interesting products. Actually, we can name, I don't know, we can spend a whole hour just talking about all the nice products created for and by developers in Google. Yeah, I don't want to even start because it's not working live very well to improvise on that part. But you can name Kubernetes, SRE techniques. So it's not only technologies, but also patterns that coming out from these big companies world. So it all started in Google in an internal project called Stubby. And as you can imagine, Google is a very huge technological company, and there are a lot of developers working on different products and different applications inside. And we can imagine, because I never worked for Google, that every team that are working on different product, it doesn't have all the constraints about the whole which technology to use, how to use it, and we as developers we can build one thing in infinite ways of doing so. That's how a world, I think, last decade moved to more microservices way of building products, and that fits the best big companies like Google. To support this way, you need to have some prerequisites in your company, because you want them to communicate, these microservices to communicate well. You need to support them well. You also need the infrastructure prepared for them, because you can imagine that you wanna, because you wanna see them logs, you wanna see if there are any incidents, if your service is not working. So there are a bunch of requirements that you need to run nicely in this ecosystem. So Google, like usual, was working on supporting and maintaining this ecosystem internally. And the project that was doing that was called Stubby, and that's where actually the gRPC journey began. But it's not only about this infrastructure, but it also about parts of the technology, of the gRPC technologies that work under the hood. And if we talk about gRPC specifically, it's about the protocols, I can say, and about transferring data through these protocols. And the second part, transferring data through these protocols, is very related to these projects that are also derived from Google, Speedy, Quick, that ended up in HTTP2 protocol, and going further than that even. The main point that here is that this is also originally used in the gRPC protocol, and later when it evolved in the HTTP2, now it's a part actually of a gRPC pattern. We're gonna explore it in a little while. So main points, it all started in 2015, so relatively young framework, but already used a lot by different projects. And it was it started in Google, but now it's fully open source. And the reason why it was open sourced quite also interesting. So we just said that it was you need to support to maintain that this whole ecosystem and infrastructure with the requirements. You want to see the logs and see if any incidents appear. Yeah, and what was the reason for Google to open source it? That exactly was it, right? You don't want to if you keep it all inside your company, you're actually very tied to your infrastructure. And if if, for example, not Google, because I can hardly imagine Google will migrate to some other cloud than Google produces itself. But if some other company was using one cloud and they decided to move to other cloud, it will be very hard if you don't have some specific abstractions and layers of a framework that allow that. And that's why it was a very nice decision for Google to open source this whole thing and standardize it. Standardize the whole microservices architecture. Hello, Dmitry. And the whole framework to community. And starting from, I don't know, maybe 2015, if I'm not mistaken, it all started to evolve as a part of a community. And now it's a fully open source product to use. So now let's back to the definition again, and we remember there is this remote procedure calls in the abbreviation of gRPC. So what is a remote procedure calls? It's one way of organizing your APIs to communicate to each other. And it's remote procedure calls, as again said. And imagine you have a huge application, which monolith application, and that you want to decompose into microservices, because yeah, you can hardly work in as a big team on a one big application. It's a modern trend to split it into smaller pieces, and then every team is responsible for their piece, and some layer behind it is responsible for communicating these microservices, these parts of application. And this is called a distributed computing system. I think this is not a new term in the software world. It all started somewhere. I don't know even when. I think it's 1970s or 1980s, somewhere. The idea is that that you have different actors of your application, but they can communicate very easily with each other. And the experience of you writing some part of an application is that you just call some function that actually exists in other application. So this is the idea of RPC. You have a client and the server parses parts of a program. You're writing, for example, your client application, and you know there is some server application, and it has some specific function. So what you want to do essentially just to call this function, receive the response, and continue running it as if it was not somewhere remote accessible, but it's just a local one. So a client program sends a request to a known remote to execute some specific program. Then a remote server needs to accept this event to understand what needed to be done, execute the function, and send back the response to it, so the client can go on. Easy as is, but it actually involves more steps, as you can imagine. First, you need some common way where your client will send a request, and it's usually called the local client stub. So you have a place in your application which doesn't have a function of this remote server application, but you can call it as if it was local. And this is indeed a local client stub. To call it and to transfer the message remote procedure, you also usually do some marshalling or serializing data about what you want to execute and how you want to execute, with which arguments you want to execute it. And then when you send this event, it will be transferred through different layers of a TCP stack, for example. And when it's received on remote part, it needs to be demarshalling, unmarshalling again on the remote server, which first will be actually received and, of course, unmarshaled, and then only then the function will be executed on remote. And then the process will be continued, but in other direction, in a back direction. So yeah, that's what RPC is, and we gonna discuss later today. But we can also imagine that this is not the only way of communicating. between different parts of pieces of application. And that's where a second part of the definition comes into my mind, the client and server communication. And in here, actually, I wanted to make a point that we always need client library to communicate to a server or between the client and the server. But it's a little bit confusing. And why it's confusing is because it also involves a client library. So the client as an actor and the client library are different things. So I put some web protocols that we know and use a lot. And actually, the software is going through the cycle. So SOAP was something that was already remote procedure calls in, I think, in 90s of last century. And then in somewhere in 2000s, the new appeared, REST, stateless transfer protocol, which is still used a lot, as we know. And later in, I think, 08, a new standard appeared, which is GraphQL, and it's kind of a combination of RPC and maybe not of REST, but RPC and something else. Let's not discuss it right now. The key idea that I want to say here is that it doesn't matter which protocol, which high-level protocol of communication you use, you always need something that is responsible to support the low-level transfer protocol. And in most cases, it's done over TCP stack, like HTTP1 or HTTP2 in case of gRPC. But it can be actually very different. It can be also in UDP or WebSockets or even server-sent events. I didn't know that this technology exists. Andrew pointed me to that nice protocol. Feel free to explore it yourself. You can also use it in the browser very easily. And when we're working from browser, we don't care about it too much because HTTP client is already included in your binary of a browser. And Google, or I don't know, maybe Apple if you're using Safari, or Mozilla is responsible for maintaining the version of this client. So you don't have any, you have always security patches. Let's say if something was found, then the client is changed, and then Mozilla or again these companies are responsible to pull it in latest changes. But you as a client of a web browser, you don't care because you have it all in one package. But you still need these clients somewhere. In a browser, it's easy, but in your server, it's already not that easy. And if you use, for example, Node.js ecosystem, of course, you have a. Oops. If you use Node.js, you of course have standard libraries already there. But you're only responsible of updating Node.js, and maybe if you're using not the lowest protocol, you will be using I don't know, maybe using some library that implements fetching of HTTP. You will be still responsible for updating these dependencies yourself. So let's back to gRPC. I hope these parts matter in this definition. So RPC and client-server communication. So let's talk a little bit about the features available through gRPC. And this is a picture of a rich official site that I will show in a second. So this shows how communication done between different services. And again, back to the previous point, client and server, every application or every part of application, every microservice can be at the same time a server or a client. So it can be both and in some way. And the execution is pretty much similar across different languages. So you have some servers running, and you usually have a stub in the application that is responsible for serializing data, serializing it to some event, sending the event. This is a part where a client library takes part, right? So it sends the data through some protocol. Then on the other side of this communication, there is usually another stub that receives this message. It deserializes message, understands what should be executed and which params should be executed. executes a function. This is not part of a stub anymore. It's your internal code of your application. Then when the response is given, it needs to be serialized again, and then again this client library take part in to sending this data, and the whole process continues. So what gRPC gives you in that sense is it helps you to generate your stub code, and then this is usually on both client and server sides. Actually, when I say usual, is because gRPC as a standard is supported by community and by Google in many different ecosystems. If you look at this page of official website, it's supported just officially in this more than 10 languages, and actually not only languages but also in different platforms. In fact, you have even the version of in a web browser that you can just do the gRPC calls, so just from your client, which is a browser in this case. Not only the browser, you also have an Android version, you have a Flutter version. As you can see, it's still very experimental, but it will evolve further. Platform environments, and yeah, and the core version. Let me actually show you this repository. This is the main repository of gRPC, or core part of gRPC. It doesn't have all the resources. It has core implementations in languages like C++ and maybe I don't know, Go or Java in here. But for example, for Node.js, which we're gonna be discussing today, has from some point in time a different repository, which is also stored under gRPC namespace. But yeah, the key thing that I wanted to say is that, however, the version is 1.43.0 of core version official. It's not the case, for example, if you use a Node version. It has a little bit different line of releases. But standard itself, the gRPC has a versioning, and I think the best is to stick to the core dependency version. Right. So again, about communicating what gRPC allows us, which features it allows us. It has a layer of a transfer protocol, and this is operating over HTTP2 protocol, which has some slight benefits if you compare it with HTTP1. For example, it allows streaming. It allows to send in data in chunks in both directions, and gRPC also has a message ordering, guarantees a message ordering. A few words about streaming. Actually, this is the first time when I show the protocol buffer example here, and we're gonna explore it a little bit later today as well. But what you can see here is a definition of some service, a hello world service. And this is essentially what a gRPC needs you to have for every microservice, a definition of a service and definition of a data that is going to be used in this service. But what we can see here is messages. Messages is kind of type of data that's going to be used in your application. And the second part is the service itself. So this is a service that's going to be executing. It has four methods. It starts with RPC in this syntax, and then it has some name, and it has a data as an input request, and the output response type of data. As you can see, hello request and the hello response feels logical. And I said streams is because gRPC from the box also supports streaming of data. And streaming is I hope you know, it's a pattern when you send your data as chunks, pieces of small data. That way you can actually be very efficient in how much memory your application takes, and it can be a limit of your application in which it's running. So it's a very nice pattern, and in gRPC it is included in here. Yeah, usually when gRPC is described, they highlight that they support 4 4 types of communication via services: client streaming, server streaming, or bidirectional streaming, the last part here, or just a single request response, which is simplest, as you can imagine. Also, when gRPC generates your code, it allows you to choose which API you want to use, synchronous or asynchronous. It has many possibilities of writing your authentication methods yourself. From that box, it supports you a way to register your service with a certificate, and then your clients or other servers that will contact you can use the certificate public keys to authenticate if this is allowed or not. So it's very secure from the box. And as we've seen in this example, this is what called protocol buffers, and protocol buffers is one of the biggest part of gRPC protocol. So it's about typing of messages, and it also about the service definitions, which is, as we will see in a minute, is not part of protocol buffers itself, but it's a nice addition, a nice plugin to protocol buffers. We're going to talk them in a second, but one more time about this picture. So you have a client. The client has a generated code stub. There is some transfer protocol involved in the process. You want to send a message. It goes through the stub. When it's serialized, under the hood, it uses whatever transfer protocol, but we know that it's HTTP2 in most cases. It is serialized as protocol buffers. It is sent to a server. Server deserializes it. It understands what to call. It calls the internal function, and then the process goes the back way. Now let's talk a little bit more about protocol buffers. It's another technology created by Google, more mature than gRPC itself. It's used a lot in many different applications right now. For example, in Kafka event buses, many different applications and products, as you can imagine. So what a protocol buffer is a typed data format, a very efficient technology to serialize it, and only about that. So it's about data types, about how to serialize it efficiently, and it's your choice usually if to use it or not. But it's just another, let's say, a zip-like technology that helps you to archive your message in a most efficient way. And it looks like that, the simplest example here. So we create some data type, message person, and then we can specify some fields in this class. We can say that this is a class of interface. And as you can see, you have some simple types included here, scalar types, and the fields have also numbers. So does anyone maybe know what numbers are? And I'm looking into the chat. Let's give it a few seconds. I don't see an answer yet, but I'll wait a few more seconds. All right. Well, finally, we don't have answers. I didn't know myself before reading the specification, of course, but you can, it's just IDs. Actually, the answer very simple. It's IDs, or I first thought it's like order in this low-level format. You can say both plus or minus, but most better actually is like private IDs, and they are very important when you need to, for example, create another version of your data type, and you still want to support the older versions, so have a backward compatibility. So these IDs matter a lot in this case. So you need to actually create a new ID, so the older IDs also supported. But that's about some way of supporting your versions of a protocol buffer. So as I said, this also started as a Google project, and nowadays also part of open source. It started much earlier in 28. And what features of this format are is, or what you need to do to write it, is essentially this proto file. You create it like that. You specify which syntax of a format you want, and after that you can use the different features of it. But what it essentially does for you, it also does some code generation, and with that you actually have some tool that I encouraged you earlier to install for your machine. It's Proto-C, Protocol Buffer Compiler, which is also supported, as you can imagine, for similar amount of languages, and actually even more. This is just official support. You see some overlapping technologies, of course, but actually, if you look at this main repo, you will find that there are much more plugins available by the community. So, for example, the official plugin doesn't support JavaScript, but its tool is very pluggable. So you have lots of things that support JavaScript, not only JavaScript, but also Typescript, which we're going to use today. And you can see Protoc GRPC is actually the library that we're going to use in today, but there are some alternatives for it. And you can choose, of course, which one to use, but we're going to practice today with this one. Yeah, and as I said, services are not part of this data format, but still can be described specifically for gRPC reason. So what this proto format supports from the box is a type of a message. This is kind of class that you can create that will be used in the protocol of your application. And with this class, you can use different scalar types. It's a pretty standard set of scalar types. You can imagine int, floats, strings, the different types of data. You also have enums available there. If you need arrays in your application, you can always add a repeated keyword, and that will be meaning that you have, for example, an array of strings or array of ints. Interestingly enough, you don't have a void type from the box. Well, actually, you have it inside a protocol buffer library, but it's not a part of a language proto buff. So in most cases, people create their own void type when it's needed. You can also create a namespace by using the package keyword in there. And the service is not part of a protobuf again, but added to gRPC, you can specify your service, and with an RPC keyword, you can just say that there's going to be a function used. It's called like that, and it's taking this data and it's returning this type of data. And we said earlier that it also supports streams keyword that allow streaming this data efficiently. I'm having this thought. I explained it already, but if you look at the face in here, it's exactly what a function looks like, right? That's what this is about, again, about RPC protocol. So what you want to do is just call some method, get some data as a response, and then use it further in your code. That's what we declare here, and this protocol helps you to maintain services in a stable state, in not using different types of data, or throw in some error and stop in execution with error code. Yeah, that's what we want trying to avoid with this protocol. And some advanced things that we will not cover today, but in this proto buffer, you also have can specify different compiler options for different languages. So usually you can see in Java code, for example, a package hello, and then some, I don't know, some options. For example, I want to generate multiple classes, multiple files out of it. So depending on which ecosystem you use, you have a bunch of options that you can use by this compiler. Also have nested types, which are not recommended to use. And in previous versions of protocol, you could use required and optional keywords, but this is kind of deprecated. All fields are treated now as optional in most cases. So be careful with that, because it's very important if you want to support versioning. And actually, there is a nice article of what versioning means in gRPC. And in one word, there is no such thing, but you need to be very careful by supporting different versions. If you update your protocol, please don't break the previous one. So reuse previous IDs, but just don't read them in your code, let's say like that. And the more advanced stuff that we are not going to cover today, some types. It supports maps, it supports some nice keywords, so one-of type, all-of type, so that kind of things. It's but pretty much that's what protobuf protocol supports. So as we can imagine, the most part is very simple. It's just not much more than we can see in this example. Right. Yeah, going fine so far. So actually, this is a part where I want to show some demos. So I don't see any questions, but feel free to ask me anything. So let me check if I have demos prepared. I think I should be. I think I will not be writing them live now, just to save us a little bit of time. So in the first demo, I want to, let me share my whole screen now. In the first demo, I want to show how to use protocol buffers, and for that, I have created in our in our repo that I showed before the demo protobuf package. And the first one, I want to show you how to create the proto formatted file, how to generate code out of it, how to use it. So what we're gonna use is a proto-C as a protocol buffer compiler. We're gonna use a Google protobuf, which is a runtime library to which contains validation for your data types. As we know, JavaScript is having types, but it's not. Those are not strict types. They are not checked before runtime. Right, it's a scripting language, so you can freely use different types, for example, for your variable. And Google protobuf is a tool that adds types to your program. And we're gonna use a small API example, this Bitcoin historical data example. I thought it fits our main business topic today, the currencies and the cryptocurrencies as an example of it. One nice thing in a VS Code, if you use in the VS Code, you have this VS Code Proto extension, and I encourage you to find it and install it if you want to use it, because it supports syntax, and I didn't use other features of that, but syntax is syntax is already something. So where we're gonna start with is we're gonna start with this historical prices. Where is it again? So yeah, it should look like that, some JSON data. So let's first download it to our file, and for that I wrote some small code. I just use some built-in standard library modules of Node.js. So I get on this API. I got some fonts, and as you can see in here, I use already streams. So I use streams that are included in standard library of Node.js. So I just pipe it to prices JSON file. Let's see if I already have a prices JSON file. No, I don't have it. Okay, then I need to execute my node index example. Hope it will work now. Let me show it like that, maybe a little bit bigger. So yeah, easy as it is, it worked. Doesn't have any a lot of code, so it was not hard to make it work. Yeah, what you got is some data which is not formatted. So let's format it like that. So we have some JSON. It has not much field. Has data price open high. blah blah blah, volume in the end. So next step I want to show you here is how we're gonna use it, and for that let's create a proto file. And I created already one, so let me open prices proto. I will show it on this part. I will do it like that. What we have on the left side is our data. On the right side, I try to type it with a proto format. So we need to create this type message. We name the price logically, and then I just specify fields that I'm gonna be using. The first one is a string date by the same name, as you can see. And then there are some floats, price, open, high, blah, 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 change percent from last month. And actually, when I was writing this example, this demo first, I made a mistake. I looked at the price and I saw, yeah, that should be int. It doesn't have a floating point here. So I created an int, and then when I was writing some other code, and it didn't work, so it took me some time to debug it, what was going wrong. But it already showed me that, yeah, this is where the difference is, because you write in an environment, and in JavaScript it's not strictly typed, but in proto buffers it is, and that's where you can potentially get an error, and that's what saves your time later when you execute different services in your application. Right, and the volume. Lastly, one more type I will create here is a prices, which is a type where I have a repeated price. So just an array of prices, and that's how my data will be used for, how it will look like. Yeah, so what do I have? What can I do after I have this proto file? Well, I'm gonna read the file that we just generated, prices.json, and then I will create a code that uses it as a proto buffer. So for that, I created the file proto.js. Let's start from the top. It has a, yeah, I still need to use some file read function. And then the interesting part. So this one is, as we can see, it's not in my repository yet, right? I don't see proto PB, which is proto buffer. And that's where I'm gonna be using a proto. I actually created a script for that in my package.json, the proto.js output, as you can see. So let's have a look at that. I added it to my build script, protoc -js output, and then you have not much options actually for from the box on a proto app compiler, but you can specify that you wanna create a common JS not comparable, but yeah, supported package from where to read and where to output in the current directory. And as you can see, I added more dependencies, but essentially for this demo, I will be using just Google Protobuf, like I explained. Right. So now let's run it. npm run build. Doing it like that, and yeah, we got a file generated, prices pb.js. As you can see, it uses here Google Protobuf. So I'm not gonna be using it in my code because it's used actually inside the thing that was generated by Protobuf itself. And then we're not gonna dive into that, but we see that that was fully generated for us. So this is this stub library. And what I'm gonna be doing, what it generated for us, it generated types, and we can create instances of this type in our code. So that's what we're gonna do. We read the prices.json. I use a common JS because Protobuf by default doesn't support. This is not officially supported in Protobuf buffer, and also not in gRPC, unfortunately yet, but there are some workarounds and some other libraries that support it. So what I'm gonna do, I create a prices instance, as you can see, the array, and then I go through my prices data and I create these instances of a price object. And then this is a function that is generated generated to this file. You can see at prices, for example. So for each field in your proto file, it creates setters, getters, and for arrays, it's at prices, as we can see. So we create an instance, we set value for each of those. And that's where I said I had an error. I put the price as integer, and on the second instance, I already got an error here. So my script wasn't running. That's why it started to work when I changed it to float. Yeah, so I convert this JSON to the protobuf types. Then I serialize it by using the serialized binary from a package, again, from generated piece. And then I put it to a prices binary file. I actually already had it generated here, but let's run it and then see if that still works. What I do next, I try to show that it's recognizable, backwards recognizable, so I can read again this file, I can deserialize it, and then by going through this list, I convert it to JSON. So let's execute, see if that would work. Proto.js was very fast, and we can see lots of JSON data is using here. So let's maybe we see the end result here, so that worked nicely. What I want to show lastly here is that if we do ls in this repository, we see the difference between the prices binary data, which is around 5,000 bytes, compared to JSON, which is almost 4 times more, well, 3 times more and something. So that's what I can, very highlight or on a high level demonstrate the difference between these two formats. The Proto is much more efficient than just JSON, the raw format. All right, that was the first demo that I want to show. And the second one is going to be also on a raw GRPC library. So what we're going to use in this one, right, we have this prices data already explored and created types of it, prices pb.js. So what we're going to do in this part, we're going to create a server, and we're going to create a client. And for server, interesting, we're going to be using the dependency GRPC.js. And previously, it was actually gRPC itself, and also supported by this core Google repository or GitHub repository. And it was migrated. And the difference between these two packages is that gRPC was more native client. So that was generated, let's say, from a C++ source codes that was generating the JavaScript code. And that was rewritten in some version to a fully JavaScript, or even the Typescript, I think it says, Typescript library in gRPC.js. And that's what we're going to use to load our server, to create a server, and to load the proto format, because that's how usually it's used in a JavaScript world. We are going to use another package, gRPC proto loader. So that part is it goes to a next point here. As a developer, you have an option how to use this gRPC. You can either to generate types similarly how we did it with the protobuf example. So we generated these types ahead of time. But usually in Node.js environment, you use a dynamic load in proto gRPC option. And for that, you're going to be using the proto loader library. So you're going to specify which package to load in there. And then you're going to start a server or start a client and check that. And I will also show streams, how they look like. So yeah, let's begin with server. This is from package proto loader. It has a better example than gRPC.js itself. Let's open the server. Have a slightly more code in here, and that's because I extended my prices proto. I told you that we can specify, created a service called history data, and has 3 methods. It has a get by date, return a price. It has a list which gets an empty, and I told you that in some cases you will create a void type yourself. It returns all the prices, and the list stream is kind of the same, but it returns a stream of prices. So let's see if that still works. Actually, I tested it yesterday. Let's hope it still works. So first, a server. What we are going to be using proto loader for dynamically loading the proto format, gRPC.js to start our server. We needed the path to our proto file, so we load the file, we load it by proto loader, and then we get a package definition. So dynamically, we got a service protocol created for us. Back to picture again when we have these stubs generated for us. So in this case, it's all done dynamically in our code. And yeah, that I think it's an interesting point to discuss. But I think in most cases, when you start your application, this starting time doesn't matter too much, right? Your service runs for much more time. So maybe it's not, doesn't matter if it takes a few more seconds, well, actually milliseconds to parse this format and generate the code for you on the fly. So I load the package definition for this prices proto dynamically, and then again I will use this prices JSON. And what I need to do next, I need to tell our ecosystem that, hey, I'm creating a server and implement these methods in this server. So I will implement all three methods: the get by some request date type, a list that just returns the whole prices JSON, and list stream will return list of prices, but as a stream. Yeah, and then when I set it to my ecosystem, I need to start it. So there is a bind and bind async function. So I think in most cases nowadays it's used bind async. And I specify on which port I'm gonna use in it. I specify that it's not secure. It doesn't have any certificate involved because it's just for local demonstration. And yeah, after that I started. So I bind the port, and if it's all fine, I'm starting it. Let me show you a little bit of implementation of the server side. So the get by date. What I'm gonna do here, I go through prices. I see if a date is the same as in one of the prices. If it's found, I will return the found price. Otherwise, I will say, no, I'm not found, unfortunately. And that's how you operate, very callback style, and I like an old good Node.js API style. When you have a callback, the first argument is error, if there is any error, or you just specify the data. And then with the list, it's even easier. A list by empty param, we don't read the param itself. We just respond with all the prices inside. And with list stream, it's a very nice, however, not as nice as it could be. So you use here almost the Node.js standard stream API, where you can write and end your stream, write and stream, as in our cases. But actually, it's not like a fully stream implementation. At least I could not, for example, use natural pipes as a Node.js ecosystem. But let's see them one by one. So this is a server. That's what the server is. Let's start it. GRPC server.js. Well, it's running. Already good sign. Next is a client, and the client starts very similarly to that. So I use GRPC.js proto loader, and for the same reasoning, I use a proto file name. I think I don't use this transform. I try to use it, but I don't use it. Let's exclude it. So next, there is a little bit different. So this is almost the same, right? I read the prices data, I create this, I read this proto definition, but I'm not creating a server anymore. I don't have to specify the service that is going to be used. I need a client. For that, I create a new client for history data on this port. Again, no certificates involved, no authorization authentication involved here. So let's begin with the first one, process exit 0. So first we're gonna send a request by date, and then let's see if that works. Node.js client.js. Okay, good. Okay, demo protobuf. Okay, that didn't work. Let's see. Maybe. Yeah. Of course, the mistake I made is process exit. It's done synchronously, and my function is executed asynchronously. So that's where what I did wrong. Let me comment it and then uncomment it. Yeah, that's how it would work. So I just send a request by date. and then I stringify the response, which is, as you can see, the pure data of a price that that data type we specified in our profile. Okay, that was not that exciting. Let's comment out. Let's go to the list one. Again, this is a very simple call, right? We executed with a void data type, and we got a response of all the array. Let's see. Yeah, we got the whole array of prices in the end, and the usage is very simple. The last one is very interesting. I use here it's a Streams API, but I use it a little bit differently. I use it kind of in a modern JavaScript way here. I got the stream by using the list stream method, right? That returns a stream, as we know. And then I use a for await in my async function that actually iterates over each chunk of data it receives. And we will see now that I will receive every price at a second, so at a chunk. And that's why it is because I use it essentially here like that, right? I go through the prices, I write every price as a chunk, and then I finish my streaming. So let's see how it would work. Stream price, and then every price comes as a data, and then pipeline succeeded. So that's a very simple demonstration, but I think it helped me a lot to understand like a role level of this protobuf protocol. And I think this is a time when we slightly smoothly move into the next part, where I will include Andrew. 1 second. Hey, Andrew.
Hello.
Hello.
Yeah,
Hey,
that
how are
was
you?
that was really brilliant, man. You just explained everything, every single bit about gRPC. I just got a couple of new things for myself, even through that.
Well, thanks for that, Andrew. I actually I think that I took more time than we expected, but maybe some raw explanation you can skip in your part then about this gRPC. So before giving you
no way.
no way.
Yeah,
Okay.
I actually have one comment about your first demo when you were using Float. This is a kind of tricky way which I experienced during implementing and trying to use gRPC in production systems. So when you use float type with Node.js, when you do encoding and decoding, because of the floating point issue, it get decoded in a bit different way, and that's a workaround how to avoid this. So you need to use the type called double instead of float. In this case, it will be encoded and decoded completely as you expect it to.
Oh, nice. Cool. Well, I have these questions just to do a more smooth transition to your part, but I don't know if they still make sense or not. So I will answer myself, but let's see, maybe you will get some comments. So why have we chosen TypeScript for this demo? And I think there are a few things few points there. TypeScript is kind of modern standard of JavaScript that is used a lot in the community for writing new libraries, and the main point why it's used that much nowadays is because it has types, and that's what a protobuf does for you. And it's very logical that you not just using the JavaScript because it doesn't have types as we know it in other strong languages. But with TypeScript and protobuf, it can be most. It's seems that it's actually there are some articles that explain that it's much more proven and stable if you're using TypeScript than JavaScript. Why we using Lerna or Yarn workspaces? Andrew, maybe that you can answer.
That's a good question. I mean, the beginning of the answer starts from the fact that we decided to build this project, like workshop example, and demonstrate how to use it inside the monorepo. So basically, when you use some certain amount of tools to put your different services in one repository, Git repository, The advantage of that, basically, you can share this code. I mean, very common code. You can share between services quite easily using the packaging system as well. Yeah, and the reason Yarn Workspaces allows you to combine all this together, so it brings a new level of abstraction for your repository and gives you like an ability to for Yarn to understand that this is a local package and it's just located next to it in another folder, for example, but not in the remote npm registry, for example. And Lerna brings just a few extra things to simplify the process of building or testing these microservices. As an example, you can have like some of the services having a test command and some of them not, and you just run one single command at the root of the project, and it does testing only the services which has this command, and the others just missed. And the tools like that, yeah.
All right, cool. Yeah, are we going to deploy?
So the short answer, no. The longer answer, not in this workshop, but in the next one. So yeah, stay
Indeed.
tuned, and it will be a bit more information about all this stuff.
Yeah, we're gonna extend this topic later with a later workshop. So follow us, and there's gonna be more workshops coming.
Yeah.
All right. So I think it's better if you share your screen now, Andrew.
Yeah, let me try to do that because I have two screens, so I just need to understand how this is gonna work. Okay, I have an
Mhm.
option to choose one. So you see my screen, right? Okay, cool.
Yeah, it's editor right now.
Yeah, great. Yeah, so first of all, it's good to start from the very basics, just to understand that the first thing, what we need to do, we need just to clone our repo with our workshop files, so you can easily start going further. And as Alex said, another very important tool for using is a tool called Protoc. And if you macOS user, it's quite easily could be installed on your computer using Brew package manager. And there's also steps to do that for the Linux users. Yeah, and what's next? So basically, we need to when we have a project, we need to just run a command. A second, just run a command in the root of this project to install dependencies. So we do that right, yarn install and see what happens. So basically, yeah, it's a little bit of preparation before the workshop, and next we just tell Lerna to install everything behind it. So when you call Lerna bootstrap, behind the scene, Lerna does installation of the packages for every single service do you have, or what you have. And now we are slightly coming to the next topic, which is so okay, we decided to use monorepo. So what monorepo is and how we utilize it and what benefits we will bring on the table. Yeah, and the benefits is following. So we divided this repo in the structure like that. So we have a folder called packages. Inside this folder, we have two folders called common and services. So common is something we utilize as a libraries between our other libraries and services as well. So this is just like commonly used inside this repo. And services, it's our gRPC services. And yeah, you see here we have another gradation of folders. So it's called services, and then another folder called gRPC. This is probably needed just in case if we have then later if we will have like REST services, which is based on Express, for example, and then we could have other tools like terminal executing commands or daemons and so on. It will be just extra folders in here. Yeah, so what else we have? We have a node folder, node modules folder. And the important thing about this monorepo, all the modules we use among every single servers inside, it's actually got installed on the higher level. So the benefit of this, we at least saving our space. So for example, if we have service 1 and service 2, and both of them using the same package in classical way, this package will be installed in here. So we will, increase our space, but gaining will be the same. And what Lerna does behind the scene, altogether with the Yarn Workspaces, they just put it in here, the real package, and here it just does some linking of this folder on the higher level, and that works just perfectly. Yeah, another interesting thing about so we have a kind of configuration for the Lerna. It's located in here in Lerna.json. So it allows us to specify where our packages will be located. So we put it like the name like packages. We also specify the npm client which we are going to use. It's Yarn. We say that we are also going to use Yarn Workspaces as it brings much more value as well. And the version of every of the package will be independent. So that means we could, have different versions inside the package.json, and that will work fine for us. Yeah, another thing to mention about this monorepo setup, there is also a requirement to add the code like that in the package.json, which this code helps to Yarn to understand what is included into your workspace. So basically, this monorepo is considered as one workspace, which is consists from different folders, as you see. We define here, so we have some part of the workspace located in common folder and part of the workspace located in gRPC. So in example, if we decide to add a REST, we will add like this. So another line in here, and it will start working. Yeah, so that's yeah, and also we have a proto folder which is located also on the higher level of the application. So every single package can know that this folder is on the higher level, and it can read it actually to start a server and start a client. So yeah, slightly we can move from monorepo setup to using Lerna. So let's try to do something like there's a couple of commands extra, like yarn Lerna run build. For example, we want to build only common packages. Yeah, just common packages. So we write like that. Yeah, as you can see, Lerna also says like filter common. So this is what we have defined in it in our package name. So for example, boilerplate, we have a package, and it starts from common/boilerplate. And what it does, it actually does run this filter against the name and do the build on every single project in here, not project, but package. Yeah. So for example, if we decide just build everything, what's going to happen? The filter won't be applied. So Lerna just does pretty much the same, but you see here, you already see 6 packages instead of 3, and it does, building of everything around it. Yeah, I will cancel this comment as my computer a little bit slow for some reason. Yeah, so Lerna bringing just extra functionality on top of this monorepo setup. This functionality can be easily used when we decide to insert all these testing steps and building steps and crafting steps into the CI/CD pipeline. So there, when we on the next workshop, when we do a Docker file for all these microservices, we will include these commands, and it will be really easy to start using this kind of a boilerplating platform. Yeah. Okay. Next, let's have a bit deeper look into the services and common packages we have. Yeah. No. Let's first have a quick intro of the proto we have here. Yeah, to have a better understanding of everything. So we have two main things here. We have a currency converter, which implements a server called currency converter, and it has just one simple method called convert. So this is what we really want to do within our application. And we have a request response, pretty much the same as Alex already showed to you, but for our particular example. And another important thing we have a currency provider. So currency provider is another service which we are going to implement. It's like an abstraction layer of this service, provider services. And here it has like one method as well. It's called getRates. So this service allows us to go to the real third-party provider, takes these rates out of him, and converted these rates to some specific format we want to use, and then just return these rates inside the currency converter. Pretty much easy, yeah. The interesting thing about it, so we define it like a abstraction format, which we don't really use in here. So it has like request and response. But then we started to implement our own servers, which called like ECB provider, which is European Central Bank provider. So we one of the interesting things which you could use in Proto, it's called import. So you can import another Proto and just instead of creating the same messages, you can just use them in here, which is really a beneficial way of utilizing your memory and amount of code generated. Yeah. So okay, what's going next? So we have Protos. We have understanding that we are willing to build some software. So basically, these Protos in general, they helps you to design your software without even starting to write any single line of code. So when you have a design on the paper, then you have a design in this Protos, then you understand some of the potential problems and how to solve them. And then you have just, the fully designed system. And then the cool thing about this system that right after that, you can just take Proto, pick any language you want, which is supported. As Alex said, there are a very, big range of the languages, which is really supported. That's really incredible. And you can build some small microservice using this Proto. On from the another side, if you decide to use another technology for some purpose, I don't know, for some reason, Java works better with XML, old outdated XML protocol than Go language. So that's one of the examples of like that, when you can use just Java to parse XML, and then on the higher level you can use Golang or Node.js or whatever you want. Yeah. So let's have now a very quick look of what common is and what we have inside the services. So the main and interesting part which we developed is called gRPC package. Yeah, it's called Go gRPC. You may ask why? Why? Is it a Go language-based library? No, that's just a bad naming. Shame of us. Yeah, but still. So what it does, what this library does, the main thing is actually the main thing of this library is to use Protoc, and Protoc is a tool which allows us to build our proto definitions into code, basically. So I will remove some files in here, so you will see, something is really happening. So we have a build command, which is partially a thing written in JavaScript, Typescript, and also some stuff is written on the Bash. We use them for this the X tool, which is another tool developed by Google, as millions other tools, but this one just allows you to write instantly a bash commands inside your TypeScript application or whatever. Yeah, so the main command here is here. It's called protoc plugin. So as plugin, Alex said, we are aiming to use protogen.ts, which allows you to build proto files. So all these files into the TypeScript files. And then we also define like where we should to put these files and so on, where are the proto located. So let's try to run just this command as it should be executed like that, just in terminal. Okay, it's finished. We see there is a folder called proto, and we have files generated in TS format. So if you open it, it's a lot of stuff about serialization, deserializations, and also we have our end methods which our services will implement, and also we will have generated a client for calling all these methods, which is pretty much easy for us when we decide to build our microservices. So we define it a proto. We use this tool to generate everything about this proto, and then we have client, we have server, and we have utility classes to send request and response. So basically we have all the communication connection issues covered by all this tool chain. And the only thing we need now, we just create our own services based on that. And start moving faster, just implementing our business logic. So let me remove this stuff one more time because I'm gonna run another command. It's called yarn build. So yarn build actually will execute this binary build TS. And it also does a little extra, apart of just using this protoc command. It does also create an index TS. And another thing, it also creates a server TS. So the server TS, it's something written abstraction of the server, how we see this server, and for simplicity, for further using in other services. So this is an abstract server which we can use for creation any of the services we need. Yeah, so it has a method called start. So it starts the server. It has a method called stop. So stop intended to be used in the systems when we know when we want to determine the exit signals from the higher level. So for example, if Kubernetes running the server service and Kubernetes tell to the service to stop, there is a way actually for the application gracefully to close all database connections, finish all the job and then really stop because of this, higher level ask you to stop. This is one of the things also shared in here. So I'm gonna run this command yarn build. We see all these pretty cool output, like what's going on. So we have sort of created a folder. We executed this protoc command. We also added something in the index to share all this stuff. And as an output, we have what we have. We have a proto files folder created. We have also index file created. Yeah. And we have dist folder created. So dist, this is a folder which contains all our converted from TypeScript to JavaScript definitions. So we have a JavaScript in here. This is not the really required step, but we decided that we really aim to distribute all our packages as a JavaScript as a final thing, which is kind of a standard in here. But yeah, you can decide just to keep it in TS and use TS from the another repo. So we have everything generated based on the Proton here, right? So what services is? Let's have a quick probably look into the services. Yeah, let's see this one. So we have not so many files in here in the service. I mean, most of the files just utility files to say like TS to process build in appropriate way, to also do some setup. We load some environment from .env, which allows us to, for development purposes, just have the file like that, and all the environment automatically loaded inside our application before we start it. And what else? We have JS configuration. We have the main thing. We have actually a server, and how we use this server. So basically, as you see, this is a common gRPC stuff we use, and basically we take out of this package like server, load options, and currency converter, as we are intended to implement currency converter in here. Yeah, so what else? So we define here options for it. We say, okay, this is called currency converter. The proto is located in here, and we create just this server which is abstracted away in this common library. So what the next step? The next step here is to start to add a new method. Basically, we know that within this proto currency converter proto, we need to we need to have this method implemented. So we need to say to tell our server that here's the implementation of this method. And we also have used some abstraction layer of this. So we added a method in a gRPC library. It's called add service. So we use it add service, and we pass like input and output, which will be provided by this method. And we also provide the method name and the original method, which is located just in another file. Yeah, so what else? So inside of the method, we just implement our business logic, what we are going to do when this method is getting called through the gRPC. And yeah, that's pretty much it, I think. We have also index.js. Yeah, but let's have a quick look on the picture I was drawing for a couple of hours. Yeah, I'm joking, not so much. Yeah, so the picture actually demonstrates what in real we are going to build. So we have kind of one service, gRPC service, it's called converter. Another service, we have provider. So all the providers are utilizing very common interface. So they receive the same request and they return the same response. But on the backend part, each of the provider can go to some provider API, whatever system. It could be database, it could be just third-party API, and fetch our rates from this third-party system and replicate them to follow our own internal format, which we invented. Yeah, so our final goal as one service, we have one main service which we intended to call somewhere from outside. It could be like inside the application. It could be also from the front end. So we want to convert some amount of cryptocurrency or another currency to another currency and get the response. So as a response, we want to see, okay, what was the conversion rate? This is the first, and the second, what the real amount I will have when I make this conversion. Pretty much easy stuff. Yeah. So we wanted to implement a couple of providers. So the one we already implemented, it's the one for Europe Central Bank rates. So if you go here, yeah, it just gives you a feed of all the rates on the following date, on the current date. And basically these rates are getting updated. I don't know how often, but anyway, it's get updated from time to time. So we just believe that this is a kind of real rates. Yeah, so what's next? Next, we also wanted to have like Bank of England. It's probably another feed in another format, but still, as I said, during implementation of each of the provider, we convert this, provider form, real provider format to our internal format, which converter will understand. And we also want to implement one provider, which is crypto rates provider. It's called Crypto Compare. If you go here, crypto. Yeah, I think this is it. There's a way to ask, for example, we want to have these currencies into the dollar. So we see here how much every of it cost in dollar. Yeah, so let's move on back to the schema. I think it's quite easy one to understand. And yeah, so the currency converter just fetches each of the provider in real time. So when we make this request, we want to convert one amount to another. It just fetch all the providers, get the real rates from each of them, and then makes the conversion based on these multiple providers. And currency providers is just a proxy to to get it simple for our system to understand that, to abstract away. So we know that this is a provider behind it, but we also say that this provider will follow certain format. Yeah.
And
We already
can
had
I
a deeper
interrupt
look
you
into
for a
the
second?
packages.
And
Yeah.
Can you increase the
Yeah.
font size, please, a little? Can you zoom in, please, a little bit? Also in your ED.
This.
Yeah, something like that. Yeah. Yeah. All
Okay.
right. Sorry.
Oh, okay. Yeah. I'm not sure how to do this inside the EDA, but let me try. Anyway. Sorry. Okay, let's try to. You cannot you recognize anything here, or what? What's the problem?
Yeah, we I think we don't have very cool quality on a stream, so it's indeed it's better to have a bigger font.
I'm not sure how to do this, to be honest. Yeah, let me try to maybe disconnect another screen which I have, and this font should be changed, but I could be disconnected for a while. Okay.
Yeah. In the meantime, I can show one more thing myself.
Yeah. Can you see my screen? Is it better now? I mean, the resolution.
Almost the same, I think. Yeah, almost the same. Is it maybe zoom like with the fingers? Would it work? I saw it. I think with a Intel. Yeah.
Okay. Yeah. Okay. That's clear. Okay. Let's yeah. Let me return back to another screen as well. Hopefully it won't stop now. Okay. Can you still see everything?
Yeah, it's a small again.
Yeah. I will do this.
Oh yeah, that like that is nice. I think. Yeah.
Yeah. So let's let's have a quick look. So what do we need to do to create, for example, a common library? So we decided to, okay, we actually good about all this stuff about the monorepo gRPC. So we want now to create a new library, common library, which we will call logger. So the purpose of this library will be to give an abstraction layer to our applications to log everything they want, and this will give some abilities like you can implement some extra logic inside the logger, which will be really helpful if you manage the big application. So we copy just the folder in common. It's called boilerplate. We call it logger. For now, yeah, we try to. So we have empty file. We go to let me do this. Just this. Okay. So we have this logger folder. Yeah, I kind of scroll up, unfortunately. So we go to the common logger folder, and first thing we try to do yarn install to install all the dependencies inside this folder, like boilerplated folder. And first error we get, it says like it couldn't actually work because we already have another package called common boilerplate. That's really important for these Yarn workspaces and Lerna to understand that there is only one package named unique in your system. So what we need to do, we need to go to package and actually change this name to logger. Okay, so let's try one more time. Yarn install. Okay, now it's worked. Something happened on the background of this tool. What we're gonna do next? So we have an empty file. It's called index.ts. So here we probably going to implement some of the methods of our newly created library. So let's do this. Like, okay, it will be debug method with a message string. Very simple implementation. Yeah, I will do this. Very simple implementation. So we have one method. Sorry, it's mistaken here. Okay, we're gonna have another one and another one. So second will be called info and error. So we'll have this here and here's your error here. Okay, we have three methods. And now we also, for simplicity of exporting this tool, we will do the following. We will export default, which just provide an extra thing for us. And we will put every single method in here. It's really slow. Okay. So our logger is pretty much ready. Kind of. Yeah, let's try to build it one more time and see if it still works. Trying to build, yarn build. And the magic starts happening. So basically during the build Typescript, internal Typescript compiler starts building its code into the JavaScript. So we're gonna have another folder called dist, where our logger will be located actually. And then we can, use this library to include into other libraries, which is our basically intention to do. Yeah, so we have this library, we have index. Let's again a bit zoom in. So we have everything converted to JavaScript. Okay, let's go to our ECB provider, for example. And what we want to do, we want to add these. We want to add a logger inside the scope of ECB provider. So if you try to do this instantly through the Yarn, Yarn will tell you like it cannot find this module inside there. It cannot find this model inside the remote registry. So that's why that's another place where we start using Lerna. So you need to be in the root of the fold of the project. You need to run yarn Lerna add common logger for sure. And what is the scope? Let's say gRPC ECB provider. Yeah, so it starts executing. Okay, everything is done. Looks okay. Let's see what changed to ECB provider. So here we see that dependencies has changed. So for now we have a dependency in here called logger, which is our own dependency located just in another folder. So let's try to go there, for example, in server, and try to use it. Yeah, let's first of all try to build ECB provider and see if it works fine. And then we will add a logger and also try to build. Yeah, if we start it, what's gonna happen? So we have Typescript just start running, and we see we use not daemon, which is a pretty much cool thing to use if you decide to write your code and instantly get updates. Yeah, so the main thing here we see server started at some port. This is a message which is abstracted away inside the server from another library. But here what we want to do, we want to add our logger inside. So let's do import logger. Pardon me, I will increase the size again. Logger from where? Okay, from common logger. Okay, it's here. So now we just say, okay, let's put here a sign logger info ECB provider has started. Yeah. And let's try to have actually the same to start the application and see if it appears. Again, this magical not daemon is doing the stuff behind the scene, helping us. And yeah, there's 2 messages now coming. So basically what we've done, we've created a common library and we use this library in another service inside our monorepo, which is, I mean, pretty cool. Yeah, so what we're gonna do like on the next, we see that common libraries works very well, So let's try now to create a service, maybe, yeah, and to see how it works. Again, for simplicity, we just copy ECB provider and try to create another service called like crypto compare provider. Okay, so this is a new provider we're gonna have in our platform, and this is already not a common library. This is a a new service, a new gRPC service. So let me like close everything, close all tabs, and I will open just this one and this one. Again, a little bit smooth. And here as well. Let me clean some code first, so we don't have all these lines from another provider, which we don't want to. And here we just return an empty response. For example, it will be currency, it will be USD, and for now just empty response to see if it even works or not. So we have this business method. We just copied all the structure. We have this business method which we go implement within our new provider. And if we see here what we gonna change here, we are in need to change this. So we need to put here crypto compare provider, as easy as that. And here just pretty much the same format, maybe crypto compare. So here's actually two things we need to define. So first of all, it's called package, and what package is? It's like a crypto compare provider. So we see package in here. So this kind of an abstraction of all other packages. So we can abstract away by packages. It's kind of like a namespace or something like that in the proto meaning. And so we need to define basically package and the service name, which we are going to implement. So this is a crypto compare provider. Here we also will change crypto compare provider has started. Yeah. Okay, what's next? So here we already have all the definitions right. We have the method getRates, and this method is getting called in here from another file. Okay, cool. So what we going to try? Let's go to this folder as well. Export this one. Okay, cd, where am I? Okay, package.js. I go to this folder first to be able to run some specific commands, commands specific to this folder, basically. The commands will be again yarn install first. As an alternative, we actually can go to the root folder and instead do yar Lerna bootstrap, which will do exactly the same, but we don't do this because it will just take more time. Okay, yeah, and again the same forgotten thing. We have the same called package already, so we have to rename it to make it work. And we just put it in here, crypto compare provider. Oops. Okay, so let's try one more time. Yeah, magic still happening. Yeah, it's done. Yeah. So we installed the dependencies. Let's try to run this service basically. Yarn. Just we will try to build first, yeah, just to see if it's no compiler issues we have, like whatever could happen in real world. Yeah, no issues so far. So we can put just yarn start and see if it will start. Hopefully it will. Yay, it's going on. Yeah, it started. You see, we have here another message provided by our logger library created in the previous example. And we have this server started on this port. And there is a an extra tool you can install. Let me move back to this. Sorry. GRPC. Oh yeah, the tool called GRPC URL. It's a terminal command which allows you basically to run queries against your running servers. It's a very good and cool tool to start with because you can easily, call your service. It could be a local service, or it could be like a Kubernetes running service. For example, to make this work in the Kubernetes, you need to do just two things. You need to, create a proxy to this service from your local and then run this tool. So for this tool, it will be called like locally, but in real, the request will be proxied inside your Kubernetes cluster, and the real server service will be called in there. Yeah, but for now, we're just interested in local execution. So few things to explain. So first thing is this is the first part, echo and some JSON inside. This is our actual request to the application. And then next we say like, okay, let's call gRPC URL, and we also want to use some specific proto. So this command understand about the format. We also say where this server is running and what exact command we're going to use. We're going to go to call. Yeah, so let's try that and see what happens next. Yeah, here. So we have this service running, right? And we go to the specific, terminal. I have everything already prepared. And here we have like crypto compare provider, crypto compare, and the method called get rates. So let's try. Okay, so we got this message back. It's a base currency, but you see there is no rates. And the reason for that, because for optimization purposes, when you do serialization process of proto and deserialization process, so we don't include any empty data inside. So when you actually serialize these to the packages, it's get crafted into one very small binary package, and this package, gets sent to the HTTP2 protocol, and then on the another send, it just got converted back first from the binary and then to JavaScript model, which we have generated. And yeah, in this particular case, there is no reason to transfer just empty data. So let's try to, add something new here. So for example, we're gonna say, okay, we have a rate, and we say, okay, it's gonna be new rate example. It will be a rate of whatever, I don't know, the currency of GBP, and the rate will be 1, 3, 4, 5, 6. Okay. So I'm not sure if it's reloaded, but let's try. It's supposed to be, but it's not for some reason. Yeah. The purpose of this not the daemon to reload automatically when I change the code, but sometimes it's just got stuck with this. Yeah, so we just restarted our application one more time to see if these changes applies to our real server. And try to call the same. Okay, we see now that there is a base currency USD and also some rates returned back. Yeah, so for now we have a knowledge how to create a common library, as well as we have a knowledge how to create a new service. But let's have a look also on the potential way how we could test this. And the potential way will be like, to use a jest. So just allows us to create whatever test we want within Node.js application. So for now, here in this crypto compare provider, we just remove all the mocking part because we don't call the real servers behind the scene. So what we are going to do within this test, we just want to create the same server. We start the server, which we just coded in here. Sorry, I'll zoom again. We also create a client to call this server. So what we have a server running in here in the test. We also have a client which allows us to call this server and see what will be the response. So in case we have a different input and output, we can play with it and see different conditions coming in and coming out. So let's try to run this test. You see, it's not really what we have in our server, but this is the expectation of the test. So it should be a base currency euro and some sort of rates behind it. So let's go back to here, stop the server. So we don't have running server at all right now. And we start, we write a command yarn test. And it starts executing this specific file we had. And what the message we have. Okay. Yeah, because here we haven't changed the method we call, and it still thinks within the test as we copy this folder. It's still thinking that on the server part it should be a method of GRPC provider implemented, but in real here we have a currency crypto compare provider implemented. So here what we need to change, we need to change here crypto compare provider and instead use it here as a client and here too. Yeah. Okay, so let's try one more time. Finger crossed. Okay, now we have another kind of error. So the test executed, and we see that on the one test what we have implemented, it's failed. And it's failed because our server returns different output compared to our expectations. So yeah, really common situation. Yeah, but let's try to fix our test. So here we have instead base currency, which is USD. Here we have GBP instead, and this rate. So we're gonna remove everything else just to get the test pass. And try one more time. Yeah, a green label. That means everything works as intended. Yeah, so for now, we also had a quick look into the just testing of this services theme. As a small bit to add, I will go to GRPC provider just to show you a bit more realistic example. So we have a test here. I will zoom it again. And yeah, what actually happens behind it? Let me close the rest, close other tabs, and open this, just to give you a bit more understanding. Again, with zoom. So inside the GRPC provider, we have a specific URL which is going to be called, and for calling this URL, we're using fetch, which is a not fetch library. And that works fine until we call all this stuff just like now locally. So we call the real server, that's fine. But when we decide to put this all these services inside the inside some CI/CD, So all these tests is going to be passed on the another server when you do a push commit. That could become a problem because the number of requests to such APIs usually are limited. So when you call it extensively, they can just block you at all. So the idea here inside the test, instead of calling the real provider, we just say, okay, instead of calling, we want to mock it. So mock, it's a extra special tool of the Jest framework, which allows us to, completely replace or partially replace the implementation of some library. So in our case, we need to replace the implementation of Node fetch, which we use here for fetching the real URL. And what we want to do, we say, okay, this function now will be implemented like this. So it will return an object which has a method called text. And this text will be like that. So that the real XML taken like a snapshot of XML taken from the real provider. But we just need one example of it. Okay, so what happens next? We do exactly the same. You see, we just call our server, which really executes this method, and then it goes to this line and it sees like this fetch method was re-implemented. So we just, instead of calling real service, we just call these implementation which we define it in here in the test. And that's pretty much cool because we for our service we can totally define the whole environment around around it. For example, this service calls other services as well, and we don't want this to happen during test of our one small piece of code. We just want to give this to this service all the environment around it, like mocked, faked, not real, with some values. And this gives us also an ability to emulate these values quite efficiently, so we can see the ways, for example, when some services return a error instead of good answer. So that's another point of view how we could handle these errors inside our service. So basically we provided this XML in here, and we provided like the result we are expecting to be returned by our service, and it should be pretty much the same. So let's try to run yarn test and see if it works at all. Yeah, it works, and it works faster because we don't really need to make a HTTP request to another server. And if you imagine like real cases when we have a database, we have many things around inside our one server, and it becomes very important and very efficient to be done. So yeah, I think we closed most everything. I just wanted, as a last bit, I wanted to show you a quick demo of what this implementation could work like. Like we have two services running, one service depend on another and using it as a proxy. But the idea that we could dynamically add more providers as shown here. So here we have a converter service implemented. We have one provider implemented, but also as a following task could be, okay, let's implement another provider and insert it into the chain, and then third provider and also insert it, and converter will start using all these providers depending on the path which rates it needs to use. And that's pretty much interesting for me. Yeah, so let's try to run ECB provider, as this is the one we already have implemented. Yarn start. It's starting. Okay, it started. We see the port like this. And we're also gonna start our currency converter as well. And see if it works as well. Okay, it started. You see here, each of them are running on the different ports, which is a kind of must. So we know each of these ports opened. So let's try probably first call the ECB provider and see if it returns real live rates back to us. And another thing we need to change is here. Oops, ECB provider. ECB provider, get rates, target. Okay, that's because of the naming. The naming here is very important, even case. Yeah, so I don't know the quality of the screen now, but you can see that we got returned the real response from the real XML, which was parsed before, and it was returned in here. Yeah, let's look. Okay, we called like we just called as an example just this thing, which is like provider number 1. But let's call converter and see if it's get called. If it calls provider 1 and provider 1 calls the provider and all this chain works, and finally we get some conversion back, which was our original task. Let me see if I have this already written in here. If not, it's not. Okay, let's then do like this convert. And here we also need to amend some stuff. It's not provider anymore, it's currency converter. And here currency converter as well, but from lowercase, currency converter. So currency converter, yeah. And here we also need to change the port because the port is going to be different. And here currency converter. The proto also has been changed. Yeah, and let's see. So what the format we actually need to put in here in this empty JSON theme. So let's go to proto and understand what the format should be. I will zoom it again. So for the request, we need to pass sell currency, we need to pass buy currency, and we need to pass the sell amount. Yeah, sell amount. So let's start with sell currency. It should be like formatted as a JSON. So sell currency will be, I don't know, GBP, and the buy currency will be Canadian dollar. So for now, we don't have crypto provider behind the scene implemented. This is going to be our next task. I mean, like our practice task. But for now, we can use just one provider to receive some output. And we also say sell amount, whatever, 100. Let's see. Okay, we got everything working. So all this schema just worked away. So we called converter called provider to get the real rates, and provider calls some other stuff behind it, like in our case, it's this XML. It's got parsed, converted to appropriate format, and returned back. So converter can do the magic and make a conversion of all this stuff. So we see, as I said, conversion rate, which is this. We also see by amount, which will be like in this Canadian dollar currency. That's pretty much it, I think. Yeah, let's try to have a quick look in here. So what we are going to do next, actually. So next we are aiming to do some practice from you. If you feel yourself ready for that, this will be really beneficial.
Hey.
Yeah, so we'll have a link here with the issues we created prior. Yeah. So, yeah, Alex, you can
Yeah,
go
thanks.
ahead, continue.
Yeah, thanks for the demo. It was really nice. I like that we first showed the very low level, right, of gRPC, and then this your part it covers basically the real case, right? You don't you're not gonna just try the lowest library, right? The gRPC JS. You need something extra because otherwise it would be a whole amount of time to make it all manually generate it and start it. So this example repository shows a very nice use case how to start all these services. And one thing I actually remember I did before our workshop, one that you mentioned, that you can have different clients, and that was the idea, right, of this technology gRPC, different technologies and different clients that can call each
Yeah.
other. Yeah, and I made a client in Java actually. Let me
Oh,
give me one
really?
second.
Wow.
Yeah, yeah, exactly. 1 second, I will share it quickly. I will hide this thingy. So maybe it's not that fancy, but I used, by the way, the official gRPC tutorial for that. So it's prices client. It's not for your Lerna repository, but for the part that I was showing before. But it's pretty much the same as we saw before. So we have this prices portal in here, and it has the same interface I was showing you. It's just I didn't implement all the calls, but I just call in the list with the empty that returns the prices. So next, I'm calling some built-in Gradle tool that generates actually the stub code for that. Yeah, where is it? Prices. Yeah, it has some pre-configuration. I didn't go into details, but the main point is that it generates a stub for us. It's like that, the stub, and let's not read this big Java code. In the end, pretty much the same. And next, I'm writing my service, a prices client, and this is a class in here, a Java class. It has some prerequisite. It has a stub here, and I'm calling the stub. I call the list method, and then I output all the data that I got, and that's a result of it. So I'm getting back the prices. I'm going through those, and it's working fine. And that's the main point of having gRPC services. And now
That's
back
really,
to
yeah, that's
yeah,
really cool. Really cool to
yeah.
have such kind of a technology, which allows us, basically to understand, first of all, this technology gives you an ability to simply design your software before you start reading anything. And then as a result, then next step, you can write your software and basically based on any language you want.
Yeah,
Really
exactly.
well.
Nice, nice. So indeed, next part is a practice. So I think let's structure it in a following way. I think we can explain issues that we created in our repo. So maybe some of you will want to pick it up right now, or maybe later. And in this case, feel free to just indicate in the issue that you picked it, so we don't duplicate our code. However, that is also fine for your exercise to duplicate work. So we actually created different issues, and we tag them if you feel yourself less into the topic, so you can you can touch it and understand it better first. And we have some advanced issues that are actually sometimes not that easy, but yeah, let's explain issues first. Then I propose we do the following. We do a little bit summary of what we just explored together with Andrew. so this session, and then we gonna meet with those of you who want to practice it, or maybe have some questions regarding the theory or practice or the project or issues or whatsoever. So we are gonna end the discussion here, and then we're gonna meet in Google Meet, where we can continue a little bit live coding or exercising or answering the questions. I think that's how we're gonna do with that. So first, I suggest us to explore a little bit of the issues we have. I will start with the last one, actually. So the one on the bottom is a create local setup configuration with Docker Compose. As you've seen in Andrew's demo, you have a bunch of commands that you need to execute in your terminal to start up services, to sometimes rebuild the dependencies, and when you create in your for example, a logger service or do a change in there, then you need to have these latest changes in all other services. So it's nice that you can use the Yarn and Lerna to decompose it and help it with it. But I think it really would be the benefit if we have a Docker Compose file which does all the trick for us, and that we created an issue. If you want to touch a little bit of infrastructure of how it all works, that would be the right issue to pick, and we consider it as a good first issue. And next one, review and update key dependencies. So also not considering it as a very difficult one. Basically, we find out while we building this demo, we were using already outdated version of key dependencies like Protoc, Typescript, for example. So if you or whoever pick this up can review which dependencies we have and try to update it, then regenerate code and start and test services. That would be really awesome. Next one is advanced level. It's actually we are picking it more for next steps for maybe for DevOps direction on this workshop. But we started building the tracing service inside our application, and we have already some code prepared for that. So it has a common library that is going to be used inside all the services. And the point is that I want to see a tracing of my requests. For example, I do request from one client, and that goes to one other service, and we use a Zipkin to output logs on these traces. Zipkin is just a service that we configured in our repo, and that can be also added to Docker Compose configuration. But anyhow, it has a README, it has a pull request, and the one small thing that doesn't completely work. And it works, but it doesn't show the connection between services yet. So that's something to explore and to fix, and very nice, I think, to if you already have advanced background on the tracing, in the whole structure of the project, and understanding of Yarn also would help, and Lerna mostly. Next one, create common library logger. Andrew, maybe you can say a few words about next ones. Oh, okay. So next one, create common library logger. I think it's almost the same as Andrew explained in his demo, but you can. It's not yet in the main repo, so maybe you can implement it yourself, and then feel free to add it to your service or to demo services to see if that works. It's indeed a good first issue because it's a comparably simple service or simple functionality to write and to include in your service. So nice to pick this up as a first one. Advanced is to create a full gRPC service for cryptocurrencies provider. It's exactly what Andrew was explaining, but we didn't implement it yet, right, in this workshop. So that's where you can it has a nice steps, what exactly you need to implement, how to run it all. So I think it's somehow in between advanced and good first issue. So if you again some background already on the infrastructure, how it all works, feel free to start working just on implementing your gRPC service. And the last two, to create a starter service for the monorepo, I think for me it's the most pleasant. However, it's not fully fully into the topic of this workshop, but it's nice to scaffold your internal services, internal functionality, common libraries. So yeah, that's something if you want to play with the npm itself, and it needs some more investigation. We made it as a ready work, so it needs some investigation on alternatives, and you can feel, yeah, you're free to choose any other alternatives, but it's just to use, for example, this library. Last one, Andrew, what is this about?
Yeah, so basically for now, how, if you open this issue, how converter currently implemented. So for now, it just takes one provider and calculates, doing all the calculation based on one provider. But our idea was to, connect to this point as many providers as we want. And yeah, so the idea to a bit refactor of this code, which we already have. Imagine if we have already like 1, 2, 3, 4, 5 providers. And so the idea, for example, here's an example. We have one rates, one provider returning us rates, which is like regular rates, and another provider returning us crypto rates, which is based on USD. So the idea to create an algorithm which allows us to utilize all these different providers to get the cross rate and understand how we can convert really one value from one currency, cryptocurrency or whatever else currency, to another. And if we couldn't, we just raise an error message like it's not supported. But the idea is to support as many providers as we want.
All right, cool. I don't know if it's a really good first issue or more advanced, but of course, feel free to play with it. And it's more about programming than infrastructure. So yeah, nice if you want to touch some really use case scenarios that we tried to explain in this workshop. Again, let's connect in a few minutes in a Google Meet. If you have some questions to us, let's discuss it there, also about these issues. So for now, we can maybe explore these issues if you haven't seen them yet. What's next? I suggest to do a little bit of summary. And before I do a summary, I want to highlight the feedback session. Please, if you enjoyed the workshop, give us a little bit of your feedback. How went it for you? Was it enough theory? Was it enough explanation on a practical on a demo part? So really looking forward to your feedback on that, and I hope you will enjoy still the coding on this exercise. And of course, if you want to help us to produce more material like that, so feel free to become our patron. We just created an account in Patreon, so yeah, something where we're growing. And now a little bit about a summary, what we today went through, the gRPC technology, the protocol buffer technologies. So I put some points in here, and let's see what our feeling is about it now. And for me, it's kind of new technology, but Andrew already in this area for quite a while. So let's compare our thoughts, I think. Yeah, why to use it? And yeah, we kind of explain the background, the layers behind it. So for me, it sounds like yet another standard. And for me, it's actually, however, it sounds not always nice that you have something yet another to learn. The key point here is that this is it's used a lot by the community, by different APIs, and it has some areas where it fits perfectly. So for me, it's actually the pro. It's a standard, and therefore it's worth to follow in it. What else? Well, it's environment and language agnostic. We saw it even with a Java client today, a small one, but yeah, you have a bunch of languages, programming languages, and environments where it's supported. And even more, you have a community around it, which brings more customizable plugins. So yeah, it's just nice how pluggable it is, and I think one of the best parts of it is that, however, it's pluggable and it allows you even more than it officially allows you to do. It's still nice that there is one big layer that is officially supported by this core repository and the core repositories to say, and therefore it's stable, and it's supported stably this supporting stably these environments. Then strongly typed messaging, of course, a part of protocol buffers. I think that's where we go in anyways, and that's where the JavaScript community, for example, moved a couple of years ago. And I think there are less concerns on TypeScript than it was where it all started. And at first it was a CoffeeScript that appeared, and not everyone followed this paradigm. But nowadays, I think almost everyone agrees that the more effort you put into writing your types, the more effort you put into make your code stricter, let's say, the more maintainable it is. So strongly typed is indeed a way to go if you want to build your application very stable, and you want to maintain it for quite a while. And that's what gRPC supports from the box, and that's very nice. And of course, as it's using protobuffer, it's very known and usable, and used efficient compact data format, which is also a very nice benefit of it. And it's also using efficient because the format itself is efficient, but it also the transfer behind it's quite efficient. I mean, HTTP2 behind the scenes, but actually one of the points in gRPC that this is a very layerable technology, and the idea is that eventually, if we migrate to some other transfer protocol, it can be I don't know, maybe web sockets, for example, at some point. Then for gRPC, it will become, and for users of gRPC, it will become almost without any problem, right? You just need to update a version of your gRPC generator, and that's it. I think it's not the point now to move to some other technology. The whole point was to use HTTP2, and so far it's still still the way for gRPC. But I think in Node.js specifically is working now on something that is called HTTP3, and who knows, in the future it's some re-implementation of HTTP over UDP and not TCP and not TCP TCP environment. So let's see, maybe in the future it will be migrated to some other network layer, and for gRPC users it would not matter much, because it's behind the box, and when it's generated you got it for free. So that's cool. And there is again one big team, community team maybe, but originally Google team, that is accountable for supporting that in a stable way. Yeah, this is exactly this point, that compiler support by community and the key organizations behind it. Nice that it's thinks over security ahead of your time, so you can actually use a certificates authentication, for example, or you can also use other techniques. We didn't cover them today, but there is a guide in official docs how you can use it. It's scalable by nature. It's all good points, and not we didn't touch it again. Free and open, pluggable. Yeah, so to have very good points to follow, and I didn't put here like a cons of this format. I think we're gonna explore them maybe in next sessions. Yeah, but to me, like this standard, it's good, but that doesn't mean that you have to switch to it. It's good in some areas. And where is it actually? Where these constraints for areas we didn't cover today. So that maybe we'll go into the next sessions. But Andrew, do you have something to add to this why session? Why do we choose gRPC? What are the good points of it? Or maybe bad
I mean,
points?
just another word about pluggability. Just my previous session I had with Is Technology, it was about pluggable plugins based on Go language, but behind all this thing was actually the company was using gRPC as a protocol, and they invented their own thing, the whole thing, how their platform can be easily extended with all these plugins. And this company is HashiCorp, and they did the same for, as far as I know, for Terraform Cloud, and they did the same for Vault, and that works pretty much good. So that allows the community to create their own plugins to upload these plugins and to use it, which is really just following some certain standard which is written and quite clear. So I think it's really good technology to look at. I won't be speaking about cons as well, but as an example of alternatives of gRPC is called JSON-RPC. It's pretty much the same. The key difference that they have all the format of the message inside the JSON. So when the messages get sent, it's just a JSON, and that's actually simplifies some parts. Like for example, somewhere in the middle, you can read this message and, for example, use some analytical tools, to instantly just do your analytics based on the messages which was sent. But in gRPC instead, you have just binary, which not so easy to decompile and to get this data out. But on the other hand, that's why it's so cheap, because it's binary. It's just, I don't know, few bytes of information. It could be completely different if you send the same in JSON. It will be much more data transmitted from one point to another. Yeah, that's pretty much it, I think. But anyway, good comparison to know the others.
Yeah, nice. Yeah, and one last word about indeed alternatives. Thanks for bringing this JSON-RPC. Indeed, I heard it, and I just yesterday attached this link. A very nice YouTube video story by Rob Crowley is also comparing this GraphQL, gRPC, and REST, and it's kind of deep talk. I think and I like that he brought the point that these different formats, of course, we all know that there is no the best tool. There is a best tool for some specific task, right? And he compared these formats, and one of the ideas that I got from it is that in most cases, it's not that in GraphQL you have that, and only in GraphQL you have that. Now, in most cases, it's always a mix of possibilities and also a mix of technologies. For example, GraphQL in some way is also an RPC. So yeah, there is a gRPC and the RPC, also different technologies. And in this small technology, I tried to start to compare it myself, like a REST RPC and maybe gRPC, I should name it, or GraphQL, because it's still different. And there are 4 measurements, like a focus on which each format is focusing. And then the rest, it's resource-based, right? You think of the what in your application are resources, because you have these nice HTTP verbs to get or put, update, or delete. In RPC, you mostly operate with actions, so your mind goes into programming paradigm, actually. And GraphQL, I'm not that sure, but I point it as a resource now, and feel free to disagree and maybe comment it later or discuss it with us. On semantics, again, REST is the easiest, I think, the simplest format from those. It's based on HTTP verbs, which is to me very nice. And RPC and GraphQL is more like programming centric, I think, for me. And if you talk about how couple the communication between client and server is in these different formats. Well, in REST is indeed is very loose coupled. You can just your API just exists somewhere in the cloud. It doesn't need to basically anyone can call it, and it will receive what it will receive. In RPC, it's you need to follow the standard. Otherwise, the generated code will not allow you to call it even. In GraphQL, it's also quite loose, but again, GraphQL is not my best point of knowledge. And the format, as you can see, in RS and GraphQL is more like a text format, and in RPC is indeed binary, like we explained today, I hope. And I think that's it then for this part. And again, if you wanna support us in any way, if you like the workshop, please share your feedback on it. And also, of course, it's nice if you wanna support us in other way. But that's up to you. So I think with that we're gonna end up. Oh no, actually, question to you, Andrew. I thought you have still a demo, right? In the end, or do you want to show it now?
I already showed. I mean.
Okay. I thought there will be still another part of it. Now that's fine. All right, then I would say thanks for joining us, and I hope to see you also on a call. But for now, we ended the stream in YouTube, and please go to the call if you want to ask us any questions.
Yeah, thank you very much, guys.